Well, hi, good morning, and thanks so much for joining me here in my shop on a gray, cloudy, kind of rainy day today. Today is the 28th of April. I'm ready to start the next step with this radio. So I'm sure I'm on my way to changing some of these capacitors, or all these old capacitors. But the last video ended with the radio clearly making a certain kind of distortion, which seemed to be dependent upon the setting of the volume control. That makes it all kind of interesting, I think. And before I start changing parts and whatnot, I think I'm going to turn the radio on and do a few voltage checks in the radio and just see if we can spot something that's out of sorts before I start changing capacitors. And maybe we can kind of come to a determination as to exactly why the radio was distorted. And maybe we can fix a single thing at that point and clear up the distortion. And in doing all that, learn something. That'd be great. So before I get going though, one of the things I want to do is visually spot chassis connections in the radio. This radio, I already know, has a negative bus in it, or a negative wire, or B minus wire, maybe that's what I should call it. I know that because I've seen the filter capacitor carefully insulated from the chassis, so the shell or the metal part of the big original capacitor doesn't touch the chassis. So that's a hint right away that the B minus wire is not the chassis itself. There's a separate B minus circuit, which is quite common in these radios, and that introduces a problem which has to be solved. And the problem is if you have no connections to the chassis at all, the chassis is just a big piece of metal here. It's rather like an antenna, and what's against this antenna is all these parts and coils and things doing things, and the chassis begins to carry some of those signals around in the radio. It can take them from one area where they're strong, and those same signals can be in a part of the radio that's very, very sensitive, and actually come right back through the radio again. You can start getting feedback. All kinds of things can happen here, not just the least of which is just a lot more noise being picked up by the radio. So to solve that problem, the easiest way to solve the problem would be to attach a wire from the chassis right to the B minus. The B minus is here, and there's a number of places in the radio where B minus can be picked up. It's cascaded through the radio on wires, and you can trace them, usually black wires too. Not always, but usually. So that would be one way. Put a solid wire in. Now here's the deal. This is a 5-tube radio, and the power cord, directly or indirectly, one side of the power cord is connected right to the chassis. In this radio it's indirect, which is what I'm getting to explaining. In other radios it's direct. In radios where the chassis is the B minus, there's a direct connection from one of these prongs right to the chassis. And it's not a polarized plug. It can be plugged in this way or that way. So when you plug it in this way, you may get 120 volts, full tilt on the chassis. And that makes the radio dangerous for people who will take it out of its cabinet, like me, and mess around with it. So you can't just run a wire to the chassis. As effective as that would be, it introduces a danger to the radio. That danger, by the way, is right out on these knobs, potentially right on the knobs, especially this one here. So in a lot of these radios, 5-tube radios, no power transformer, they're built so these knobs don't even protrude these shafts rather. When you pull the knob off, the shaft is still inside the cabinet. So you really got to work at touching the chassis in a lot of these radios. A lot of them have a external antenna connection like this, and this will be protected by a capacitor. I really haven't gotten into how the chassis is protected yet, but yeah, why don't we do that? So how are you going to manage to quiet down this floating piece of metal here, and yet maintain some level of safety, so if some goofball like me grabs onto it and then grabs onto my local water tap, that I won't end my life? So the way you do it is you make a high resistance connection, or a high impedance connection, between the B minus here, and the chassis. The easiest way to do that is through a capacitor. The great thing about that is the capacitor's reactance is low at high frequency, so high frequency stuff on the chassis sees the capacitor like a short circuit. The low frequency stuff, like 60 cycles, like the stuff in your outlet, look at that capacitor as a much higher impedance. So if you do draw current from the B minus through the capacitor that's connected to the chassis by touching it like this and grabbing your local water pipe, you'll only draw enough current to make you jump. You won't draw enough current to kill you. That's the theory. Often these capacitors are paralleled with a 500,000 ohm resistor or so. Not always, but often. As we've been sitting here, as I've been chatting and talking, I've noticed that there's a piece of solder right here and here. Yeah, I think it's nothing. I thought for a minute, well, there's evidence that these are all replacements. No, I don't think so. I think these are all originals. Okie doke, so where is that capacitor? Where are the connections to the chassis? There's more than just the capacitor and the potential resistor. So I've scouted these out a little bit already. In these radios, and you have to look close to see this, the tube sockets, which are riveted in. See, there's a rivet down here, riveted into the radio. There's a rivet up there. The outer part of the tube socket is like a metal cowling, if you like, holding the plastic part of the socket. It's riveted right to the chassis, and it often comes with a couple of terminals. So you can make a connection to the chassis on a terminal on this tube socket, but not one of these terminals up here. It's another one in the back. Can you kind of see it there? Maybe you can't really see it. Oh, you can kind of see something back in there. There, you can see it now. That's this one here. So you look close, you can see it's actually connected, and there's the rivet, and there's everything. So this capacitor is connected, one side anyway, to the chassis. Now you have to look close, but there's another wire coming up from down there. It's coming right up to this terminal on the tube. This is terminal 1. On terminal 1, on tubes with metal tubes, like that one, pin 1 is almost always just a connection to that metal shell. And you can think of the metal shell as just more chassis. In fact, in this case, the metal shell is floating right on top of all the tube elements. So if you don't do something about this metal shell, in terms of draining out any signals that might be in it, this thing will act like an antenna for the sake of all the stuff inside the tube. They're going to pick up a lot of stuff. Now, in the old days, of course, what they did was they didn't use a metal encased tube. There's a glass tube inside there. They used glass tubes, and they slide a metal shield over it. And then that shield would have to be connected back to the chassis, and the chassis connected back to the B minus, or on bigger radios. In bigger radios, it's a different situation, so I won't go into that right now. So this tube has a metal shell, and there's the connection. Okay, the tube, I'm just looking to be sure. The tube in this socket has a metal shell, and sure enough, there's pin 1, and there's the connection right down to that terminal. Another tube with a metal shell on it. I think there's 3 of them in here, isn't there? Yes. This one. So again, if we look for pin 1, so I'm looking for the key here. So this is pin 1 right here, and sure enough, there's a wire going down to the chassis. Now, I did a radio a little while ago where the tube shells had their own drain, their own capacitor and resistor back to the B minus. This radio, the shells are going back to the chassis, and the chassis is going back to B minus through this capacitor. And is there a resistor paralleling it? I don't see one in here. You might notice too, this is a fairly fat capacitor compared to these other ones here. He's a fat guy. Now, it's just to carry on with the safety yapping here, and don't, take everything I say with a grain of salt. You got to use your own brain power on everything, including stuff that comes out of my mouth. What happens if this shorts out? So I don't think you'd notice anything with the radio offhand. But if this were shorted right out, then there'd be a solid connection between the B minus and the chassis and one of these. So depending upon which way you plug it in. So if you want to know more about that problem I'm talking about, it's called the hot chassis problem in a 5-tube radio. If you're thinking about doing this kind of stuff as a hobby and you're new to it and that, you need to read up very carefully about hot chassis, 5-tube radios, radios with no power transformer, radios that have their heaters in series. So all that stuff adds up to one of these kinds of radios. This is the kind of radio somebody will grab and think this would be easy to work on. And you're quite right. It's compared to other radios, it's easy to work on, but it comes with this danger that may not be obvious to someone just starting out in this work. Lots of great places on the internet to read about this. One of the sites I like is the place where I go to buy my capacitors. In fact, Just Radios. Just Radios has some well-written information about radio repair, and especially this particular safety issue. So, okay, I'm talking an awful lot. Many of you may know all this already. In fact, you may know it better than me, for crying out loud. So, you're listening to me go over it, but okay. So that's a lot of talk about the chassis, and why so much talk? Because I have to decide what to do with this. This is the ground wire to my meter here. This is the testing probe. This is the ground wire. I got to decide where to put this. I have my choices. One is, notice the radio's not plugged in right now. Go here. Or another place is right on the B minus, way up in here. The one that's best for sure is onto the B minus. There's another spot I can get it on this terminal here. Maybe I can get a better grip. I'm looking for a way to clip this in where it won't wander off. Okay, that's pretty good. That's not too bad. So this is now connected to the same spot as here. There's a wire that runs from here to here. It's all B minus stuff. So I'm ready to test some voltages now. Okay, we're ready. I'll power up the radio here. So like always keep your eye on the dim bulb. First turning it on. Whoops. How about we plug it in first? Oh. Okay, this is plugged into an isolation transformer. Neither of those. There's no. I'm not sure how to say this. I was going to say there's no relativity between the 120 volts here and Earth. That doesn't make a lot of sense. I don't think that's a good way of putting it, but let's just say because of the isolation joint, I cannot complete a circuit by touching the radio anywhere, and touching the ground, say with my foot. But I would never test it out. Okay, volume down, switch is off actually. Okay, switch on. Generally, I don't like to operate these switches when I'm turning on a radio like this because you're essentially grabbing onto the chassis at the moment you're energizing it. And surprises happen. I guess that's the last part of that sentence. Okay, is it really on? Yep, tubes are warming up. Sound is coming out. Well, that's a really nice hiss coming out of this radio. I love that. Now, we don't have to listen to it too much. Turn it down, just ignore it. The supply voltage, because we're going to be doing voltage checks, 116 volts. So that's the antenna right there, and the cord appears to be Funny, it just makes a bit of a hiss. Okay, we will just ignore that. First thing we will check is see what the B plus really is. My meter here, we're going to use my great meter here, DC plus, 150 volts, full scale. My probe is set to DC, puts a little resistor in the circuit here. We can pick up right here, I'm watching the meter now. So now that's telling me at this point the B plus is all of 77, 78 volts. I'll go on the other capacitor here, much higher, 110, 110 and a half. I think that's what that says. 110, no, 114, 114. Okay, need to practice reading my meter. 114 is okay in a radio like this. You can get higher. You know, you're starting with 120 volts. And if you full wave rectify 120 volts and do it very efficiently, you can get 169 volts out of it in a power supply in a radio like this. But you'd be lucky to get 140 in most cases. This one I think just has a half wave rectifier in it, so you know you're down around 110, 120, just like it is here. Now, is that voltage making it to the tubes? So we know the sound was kind of a choppy quality to it, or a limited or cut off. That's the word for it. When we listened to it at the end of the last video, to me it sounded like a cut off sound. So let's check which of these is the output tube. So that's rectifier, that's output tube. Now I gotta get the right pin here. Or we can just go right around all the pins. Why don't we do that? We'll go right around. I won't even know what they are offhand. So first pin is pin 1, it's open. Pin 2, so you're just watching the meter over there. Okay, pin 2, probably a heater. Pin 3, you can hear it. Probably, well, look at that. So that's 110 volts. So this is probably the plate right here. Now there's a screen in here too. Oh, here's more voltage, much lower, 77. That's probably the screen. Now, so we found 2 high voltages on this tube. That's good. One of these should make the tube go backwards, or make the meter go backwards. That one. That one makes the meter go backwards just a tiny amount. How tiny an amount? So we're on 5 volt scale now, and I flip the meter so negative is upscale. What's with the sudden jump downwards there? There we go. So we're on like 5 volt scale, not even a volt. That doesn't sound right. Okay, don't know for sure this is the grid yet. And let's carry on back to 150 volts. And we're just about done here. Tiny voltage there. What would that be? Okay, so we saw the 2 high voltages. So I got a couple of choices here. One is look at my book. I think I'm gonna do that, or pull up the schematic. We'll do the schematic in a bit. So this is a 50L6. A 50L6. I want to find the pinout. 50L6. Looking at it here. So it's pin 5 is grid 1. Let's take a look at pin 5. And pin 8 is the cathode. And we can guess there's a cathode resistor on it. If we look at pin 8 right away, 2, 2, and around 20. This is 220 ohms. So this is probably the cathode resistor. What's this great big one then? What's this big guy? This might be the heater. This might be the heater resistor. There shouldn't be a heater resistor in here. Okay, so to explain what I'm mumbling about, this radio, according to its own information, has a 35 L6 for an output tube, but what's actually plugged in there is a 50 L6. They're the same tube with different heater voltages. This resistor makes the 35 L6 work. 50 L6 is not enough voltage available in the radio to get 50 onto the heater here, if all that thinking is correct. Okay, so going back to what I believe is the grid now. What did I say it was? I have a bad habit of closing the book too soon here. 50 L6. 5. Let's look at the voltage on pin 5. Voltage on pin 5. Should be a negative voltage. Should be a negative voltage around 10 volts or something like that. 5. So counting. 1, 2, 3, 4. This is 5 here. So we see there's a negative voltage. You can see my meter going up a little bit. Same thing I measured before. Half a volt. What does the book say it should be? The book will give us a hint as to what it should be. Heater current, 150 milliamps heater current. Maximum ratings. Typical operation. Grid number 1, control grid voltage, -7. Cathode bias. Well, they didn't put the resistor in there, did they? It just says cathode bias and leave it blank. It must be down here somewhere else. Must be maybe under ohms. 4,000 ohms. 28,000 ohms. 180. So there we are. So that's the cathode resistor there, I bet. Cathode bias resistor 180. So in this radio it's 220. Yeah, 180, 220. It's 180 with 200. It would be, so at 110 they don't have fixed bias here. You'd think it'd be a smaller resistor, but it's 220 in this radio. Well, why is it? Why? So if we look at the cathode, then cathode is 8. 8 is right here. So this should read a positive. I'm getting this a little mixed up here. So I did warn you about paying it. Don't pay attention to what I'm saying. Cathode voltage showing positive is the actual bias reading. Here we are. I'm on the 15 volt scale. On the 15 volt scale, we're about -5. Okay, not nearly as bad as I thought. If I really want to read the actual voltage difference between the grid and the cathode, I need another voltmeter without I wouldn't want to use this kind of voltmeter and just read between these two terminals. But actually this is not so bad. So what I was worried about here was that the grid was being pushed positive by a leaky capacitor, and it's still possible. So I'm pondering the color coding of the wires in here. I see there's a lot of yellow wire. Red wire is almost always a high voltage wire. Green wires quite often are, in this case it's just plastic covering on wires. It's not actually green insulation. But green can be AVC. Different radios have different color coding in them. What to do? I gotta figure out what this guy is. So he's hooked up to pin number 2. So these tubes often, pin 2 and pin 7 are the heaters. It's definitely on pin 2 here. And There's nothing else hooked up to pin 2, so whatever gets to pin 2 has to go through this. We come over to this next one. It's pin, I think it's pin 7. The resistor is hooked up to pin 7 over here. Oh, now that's the rectifier, so that's the rectifier, right? Pin 7 on the rectifier. Okay, 50L6, pin 2 heater, and 35Z5, 35Z5. Don't be surprised now. 35Z5, pin 7, heater. So this resistor is in there because the radio is built for a 35L6, but it has a 50L6 in it. So what this will have done is it will have caused the voltages on the tube heaters to not be correct. Exactly who the loser is hard to say offhand. It could be all of them are running a little low in voltage. Could be one in particular is running quite low. They're all getting the same current. They're all getting the same. Well, I think what I just said is probably not very true. They're all getting the same current. 150 milliamps. But you want the two tubes here, the rectifier and the output tube, to develop a lot of thermal energy, a lot of heat in their cathodes. Not so much for these guys. So you want the wattage to be down here. And that's why that's a 35, and this should be also a 35 L6. The 35 volts coupled with 150 milliamps gives you a lot more power than the 12 volts coupled with the same current. So you get hotter tubes because these guys are working hard. These other tubes, they're loafing. They're loafing along doing signal amplification, and their load is another tube that doesn't draw much. There's no load. These guys up here, they're kind of on a vacation, but these two are working hard. Just measure the heater voltages. I'll measure the heater voltages. I'll do it with an isolated meter, so we can actually measure right across the heaters themselves. So I'm hoping today to get some capacitors changed, but I might not. I might just end up doing this poking around thing. I'm enjoying all the talk right now, so hey, nobody argues with me. It's fantastic. 20 volts AC, and we're looking for higher than that. We're looking for something like 35 on the 50L6. I wonder if that's what would... No, that wouldn't necessarily happen. Stop wondering and start measuring. So, pin 2 and pin... Why don't we just take the voltage drop right on this resistor right off the bat? How much voltage is it stealing from the other tubes? Stealing 8 volts, 9 volts, 12 volts. It's stealing a full 12 volts. Take it again. 70. Ooh, wait, I did something wrong there. Yeah, wrong terminal. Wow, those are almost shorted right there. Holy smokes. Stealing 12. Stealing 12 volts, and we're feeding the radio with 115. 12. Well, you know, if it's 12, there's 5. That's 2 volts a tube. And on these two larger tubes, a couple volts, not going to make much difference. But how is this guy ever going to get to 50? He's not going to get to 50. It looks like it though. Okay, we'll read the actual heater voltage now. on the output tube. As soon as I convince myself where I do that, here, and $50L6 with 41 volts on it. Now we know where 10 of them are lost in here. Now let's try the rectifier. 2 and 7 on the rectifier. Two and 7. 7 is this one again. 35. It should be 35. 31. So that's just about all the voltage right there, isn't it? Because there's 12 here, 4 or 5 missing there, 10 missing there. The other ones then should read their typical, or their correct. Let's try this too. It's pretty much in the clear. So 2 looks like the yellow is the heater. The yellow wire is the heater wires. 2 and so we should get 12 here. 10, so it's a little low. Up here, just using the yellow wires now, not even paying attention to pin numbers, but I can see it's 2 and 7. Don't touch the chassis while you're doing this. Can anybody see the meter? 10 again, 11, 10, 11. So the solution here. I remove this resistor. 12 volts will find its way across these tubes. The 12 volts is all going to show up on this 50 L6. I think the answer is yes. Is this the reason why the radio is distorted? I just don't think so. I don't think so. I don't think this is the reason. Okay, having gathered all that information, we can move on. Keep going here. I'll have to stop just at that. There are other tubes to consider. Okay, so we're set plus 150. Go up to this tube and just try to find the plate voltage. I'll just start here. Just going at random. Well, not quite random, going around in a circle here. Oh, the meter's not doing much at all. Is it up? Alright, up. Okay, so that's the big ground there. Hey, where's the voltage on this too? Something not correct here. Did I just miss this terminal? That terminal I just did is, I think it's part of B minus. I can't see with the clip there. This terminal is connected to the chassis. And that's oh, it's not the chassis. No, there's a wire heading for the chassis connection, but it's actually a resistor down buried under there. Okay, just misseeing it. This one is the one that's connected to the chassis. So that's pin 1. Okay, we'll go around again. Here we go. Pin 1. Is there something going on here? Oh, I'm going to check the meter. Meter's working. Pin 1 gives you nothing. Pin 2, nothing. Pin 3, nothing. Pin 4, negative voltage. If anything, the meter's actually going down, and I can hear it in the speaker a little bit. this pin's connected to this one. They're connected together. Oh, this is probably the detector. These are probably, this is the detector tube, and this is probably the detector plates right here. You can see they are connected to a terminal that goes right up into one of the coils. One of the IF coils. So that's what that is. And then I'm not finding any B plus on this tube. Went all the way around. And double checking the meter. The meter's definitely working. Okay, so I think we found a problem that can cause exactly the kind of sound we're getting. And that's right in this detector tube. No B plus. I think we're going to have to look at the schematic at this point. Okay, let me just turn down the radio so we don't have to listen to that. And here's the schematic for the 5000, the model 5000. And the tube I'm interested in is the first tube right here. No, I'm sorry, last tube, this one. This one right here, detector tube. So let's zoom in on that. Okay, so here's the two diode plates, and you can see they are joined together, and then they disappear into the secondary of this IF transformer, just as I saw. And that's hard to read, but I think it says 58 volts there. That's quite common for a plate voltage. The pin numbers are not written here. There's a good chance this is shown. No, maybe not. There's the no. Well, you know what? There's the key. So I think they're trying to show these the way they actually are. So yeah, like a pin, maybe counted this way. 1, 2, 3, 4. Maybe the other way. 1, 2, 3, 4, 5, 6. 12 SQ7. So I'm just going to take a quick peek in the book here for 12 SQ7 and 12 SQ7, and which, so pin 6 is the plate. 7 and 8 are the heaters, just like it shows here, yeah, 7 and 8. And then pin 6 is the plate with the 56 volts written on it. So the diagram is pictorially correct. So why didn't I find 50 something volts here? So let's see how the voltage gets here. It comes on this wire. Okay, this capacitor blocks DC. So it must come up this way, coming from this wire. This wire is energized right from the power supply here. So that's the B plus. So if there's voltage here, and I'm sure there is, and no voltage here, it's got to be this resistor, resistor number 15. Number 15, and number 15, the resistor is 220K half watt. 220K. So that would be red, red, yellow, I believe. So look for red, red, yellow near that tube. Okay. Red, red, yellow. First of all, because I turned the sound down, I'm at risk of being electrocuted, so I'm going to turn off the power. And make sure I'm looking at the correct tube here. Pull this off, get it out of the way. Red, red, green, right there. And what about that one that's hidden way in the back there? I can't even see it. That's a red, looks like red, green, brown, or something like that. Red, red, yellow. There's one underneath this capacitor. Is a red, red, yellow. There he is. Red, red, yellow. Is that open? Is that open circuited? Voltmeter. Okay. Ohmmeter. Meter of some sort. Let's try to get everything in view here. Okay, did we find an open resistor? Where's the lead? Cool, I can get it right there. Got one right here. My Jove, it looks open, doesn't it? Go higher. 200 million ohms. Man alive, that's almost all the ohms there are available. Nope, there's no ohms there. It's an ohm-free resistor. It's empty of his ohms. Now, we're going to cut one leg off. Sounds painful, doesn't it? Ooh. And then we're going to test them again. And this will be the cause of all of our problems. Low volume, distortion, if it's a zero. It's a zero. It's a dud. Okay, here we go. Now I just got to change that. Get a new one, stick it in there, and we'll test this radio again. Okay, I've got two resistors here to pick from. Let's just check them. Zero. Isn't that red, red, yellow? I guess not. I guess that's brown, in fact. Okay, well, we don't want to use that one. Let's try this one. This one's pretty clearly red, red, yellow. There we are. 220. Close enough. This kind or this style of resistor where there's actually a little end cap on each end there. And that end cap is the connector into the resistive element inside the resistor. I find with these, if you bend these wires a little bit too much, the end cap pops right off, and the resistor is no good. So I don't like using these. I have a bunch of them, but I don't like using them because I'm so afraid to bend the wire. And this is a big resistor, having to go where a small one was. Now he's got a lead on him. Where's that lead going? Where is that lead? It's going down to this terminal here. Yeah, B plus terminal. Red wire. Red wire to there. So resistor length really isn't a problem. Okay. Don't think this green wire is going to be of any use. I'm going to get at it here. There it goes. Got it. There he is, one dead resistor. It's a little too stiff. Put a little wire cover on here. This is a hard way to work on this radio. I'm doing it the hard way. Let me get that resistor in there and then we'll test it out. Okay, this is a lot easier to see what I'm up to for both you and me. I just want to kind of fish this in here. Go. Probably smart to solder that before doing the other end. Now, just need to so I'm trying to grab the wire so it stops the bending where I'm grabbing the wire. Bending won't go right up onto the resistor. That's kind of what I'm trying to do here. I want this capacitor is not long for this world either. No. It's not going to work well. Okay, just go around. Yeah, I'm muttering here. Muttering. So I'm trying to leave the original capacitors in so we can find out what happens to this radio with its original capacitors. Good. So otherwise I just cut this out of the way and replace it now. But it's not, this is more fun. Yeah, I try to let fun be a driving force when I'm doing this work. What appears to me to look like fun may not look like fun to other people. I'll tend to go that way. Because if you're doing this kind of stuff and you're not really doing it for money, why are you doing it? For fun and maybe value. Maybe you want to create value. You're going to take a junky old radio and turn it into something that's, you know, worth $25. Maybe that's a good reason for doing this. Okay, so we got that resistor in there. It did a good job on that one. Excellent. Don't play with it or it won't be a good job for long. It's just about time now to turn the radio back on and see what we did to it. What did I do to it? Okay, let me just make things a little safer here. Flip it right over. It still has the heater series resistor in it. It shouldn't be in there. I have a couple choices here. One is leave it, just leave everything. Another one is stick a 35L6 in, yeah, correct tube. And the last one is cut out that resistor and get rid of it and leave the 50. Those are my options. Okay, so volume down because I think we're going to hear this radio for the first time. Let's just do one more thing here. Is it really bad? Watch this. I'll put this on and it'll test perfectly. No, it's really bad. So you gotta wonder, what has happened to it? That it's got nothing. My guess is the leads have lost their connection to the resistive element inside. That would mean pushing on them might do something. Oh, don't stick your fingers on it. But no. She's done for this world. Okay, dead soldier in the garbage can. Power. Eyes on the light. Cooking with gas. 113, 112 volts. Tube is lighting. We're in business here. Give it a moment. It's more dramatic if I let it warm right up before I turn up the volume. No particular hum. A little wee bit of hum if you stick your ear right in there. Lovely. Lots of volume. Now, we're going to tune something in. Does it have that same distortion?
Care Center, a retirement and long-term care facility in Hagersville. It was owned by and operated by the defendant, and they stated it states that she died alone of COVID-19 related complications on March 30th. She had complained about neglect, but the first time that the family heard about it was when they received news of her death. Is that the case?
So there's a certain amount of what's being talked about here in Canada is the situation with old folks in the long-term care home system, and in Canada I think it's similar in other countries, of course. COVID has found its way into the long-term care system. It's really bad here in Ontario. I think 60% of the people who've passed away have been in long-term care facilities. So that's a sad situation here, and I think it's common around the world. So a little bit of distortion still. Some of that could be from this. Let's hear it again. Let's try the sports station. Sportsnet 590. Nope, don't play the music. Don't play the music. Oh my gosh. Okay. So, we found a big problem in the radio. Big problem, little resistor. So, the radio's working really quite well now. Questionable as to whether I should bother changing any more capacitors in it. Oh yes, you should. I heard you. So, we will look at that on the next video and consider going further with the radio even though it's working pretty good now. I certainly have to deal with this. Great. Thanks a lot for watching, and have a great day, and I'll be here again tomorrow morning.